Hello, everybody. I hope you're all enjoying the weather today, getting the nice spring day in. So today we're going to keep going on triangles and similar triangles and proportions. And we'll get to this question in a bit. It's just a little teaser. Let's see. So now let's go to the next real question. Great. So you're standing X feet from a lamppost, 20 feet tall. Okay, perfect. And your shadow is 12 feet long. How far are you from the lamp post? Okay. So on a question like this, right, we want to try to visualize it as much as possible to get what we're doing. So there's a lamp post. It's 20 feet tall. And then you are some distance away from it, right? And you're 6 feet tall, you know. And then the distance is here and it's X, which is what we're going to be looking for, right? And then they tell us this other piece of information about the shadow, right? Your shadow is 12 feet tall or 12 feet long. So now what we're going to do is what happens is the light goes from the lamppost, hits the top of your head, keeps going at the same angle. So it forms a triangle here that is the same in proportions as the big triangle, right? So this is a similar triangle problem, and we want to find what X is based off of that, right? So we're going to set up proportion, right? This side, the 6, is to 12, what 20 is to the whole bottom. So what you could do is do 6 over 12, right? Over, or equals 20 over X plus 12. X plus 12. And then you can cross multiply and solve. But what I would like to do before we cross multiply is simplify on the left side to make the numbers smaller. And that'll decrease our chance of messing up. So the 6 becomes a 1 and the 12 becomes a 2, right? Because 6 is 1/2 of 12. And now when we cross multiply, the math is going to be really nice and clean. 1 times, so we'll do it like this, right? It'll be boom. You don't need to do this for yourself. I'm just doing it to illustrate. And on the test itself, you don't even have to show any of this work if you can do it in your head. So we're going to get 20 times 2, right? And then we're going to get X plus 12 times 1. So it's just going to be X plus 12. And now I'll just put the 1 just for illustrative purposes, right? And now we're going to do 20 times 2 is 40 equals X plus 12. And now we can subtract 12. Subtract 12 and get 28. X equals 28. Okay, perfect. So in this one, there's not too many big mistakes people make, but the big one is you rush through it and you think, okay, 6 to 12, 20 to what? And you get the 40 and you just put the answer down as 40. But that's not the whole thing, right? Because it's asking for the distance here, which is 28. Obviously, it doesn't look like 28, but that doesn't matter. It matters that we are able to figure it out from this, okay? And it matters to know which part you're solving for. You're not solving for the whole bottom, just for the distance between them. Great. All right, and now let's go to the next one. In AB, or AB equals 12, BC equals 14, AC equals 10. Okay, so we have these 3 values. These side lengths are for triangle ABC. Okay, that's helpful, which is similar to triangle DEF. Okay, helpful too. If DF equals 8, what is the side length of DE? Okay, so remember in similar triangles, the corresponding side lengths are proportional, right? So if in one triangle, one side length is double the corresponding side length on another one, then that triangle, all their side lengths are double the other one. And also remember that the way the name of a triangle is written tells us the position, the corresponding position. So we say A is at the bottom left. We could say it's anywhere, but let's go there. And B we could put there, right? Right now we can do it anywhere we want, but this is how we're starting. So then we know AB equals 12, BC equals 14, right? And AC equals 10. And this is really good to draw because it's hard to keep track of order of everything just in your head because the letters get used twice each time, right? So now we're going to draw another one. And this one is going to be DEF, right? We can make it look. And now here the order of the letters matters because DEF, right? It goes A first, D first. So D has to go where A goes. B second, E second. So E has to go where B goes. And C third, F third. So F has to go where C goes. You just have to remember that. That's not too hard. It's pretty intuitive, but if you don't know it, now you know it. Normally I go the other way anyways, but it's okay. So now this is our new triangle that's similar to our old one, and we have DF is 8. So now we can find, oh, DF is corresponding to AC, which is helpful, right? So we can say, you know what, I'm going to make another 8 because that one I wasn't happy with. Great. Okay, so now you can do 8 over 10, right, is going to be equal to something over something, right? And what are we looking for? We're looking for DE, which corresponds to AB. So we did this triangle on top. So we'll do it again on top. So we'll say DE over the corresponding part in the ABC triangle, which is AB. Great. Again, we want to cancel here. 8 over 10 becomes 4 over 5. This one is not as big a deal because dividing by 10 later is pretty easy, but just for good practice. So then here we're going to do DE times 5, right? So 5DE equals 4 times 12. Okay. And now we divide by 5. Divide by 5. Perfect. And we're going to get 4. And I usually like to divide before multiplying because I know I didn't do it on the last one. But then if there was something we could simplify and cancel, it would work, right? Like let's say 4 was 25. Instead of doing 25 times 12, which could be tricky, we can do 25 divided by 5 and then multiply by 12. But here, it doesn't really help. There's nothing to simplify, but it's still good practice. Okay, so now this becomes DE equals 48 over 5, right? And that is 9.6, but we don't have that as an answer choice. It's 48 over 5. So we get 48 over 5, right? And doing great, loving life. These are nice and straightforward right now. Now let's go to the next one. This one's a little trickier again, like last time, but I think we can do it. So in the triangle below, what is the sum of AD and AB? Okay. So we've been doing this exact type of triangle for a few days now in a couple videos. And the key, right, is when you're dividing the right angle here and making another right angle across from it, the triangles you make are similar to each other and similar to the big one, right? So it's going to be, again, I might sound like a broken record to some of you, but hopefully it'll help it stick. ABC, which is the big one, is going to be similar to A, right? Because that's the same angle. Right now I'm going to focus on getting the big one similar to this triangle. Okay, so A. And then B was the 90-degree angle in the big one. So what's the 90-degree angle here? D. And then the other angle left is B, right? So this part of B is the same as the C from before. And now I'll try to find the similarity and corresponding parts in this one. So let's go with C here, right? Let's, in the big triangle, C was at the last one. And here in the little triangle, so we'll put C at the end again. And now the 90-degree angle is, when the big one was B, and the 90-degree angle here is D, like in the other small one. And then what does that leave us with? It leaves us with angle B. Okay, so now let's find what we can find. So we can find DC based on our old friend Pythagorean theorem, right? As a refresher, right? Pythagorean theorem is, I'll put it inside this triangle, a squared plus b squared equals c squared, right? And that just means the side length squared summed up are equal to the hypotenuse squared. So here we have one side length, 6. We're missing this one, which let's call this one b. And we have the hypotenuse, 10. So then I'll write it right below, 6 squared plus b squared. And you don't have to use b. You could use d. Well, I guess you could use d. You could use x, y, j, whatever letter you want, right? But I'm using b here, lowercase b. 6 squared plus b squared equals 10 squared. Right? And then this makes it into 36 plus b squared equals 100. So then b squared equals 64 because you subtract 36. And then you get, I'll draw a little arrow, b equals 8. Now, I did it a long way, right? What I really want you all to be able to do is to do that in your head and not even do the math, but to recognize you have a 6 as one leg, you have a 10 as the hypotenuse, and the ratio there is 3 to 5. So what you have is a 3, 4, 5 right triangle, right? So that's the base, 3, 4, 5, and then everything gets doubled. You could triple it, right, and get 9, 12, 15. You could multiply it by 10 to get 30, 40, 50. It's the ratio, and if you see that ratio, you should just be like 4/3 of 6 is 8. That's how you do it. You don't have to use Pythagorean theorem. But the beautiful thing about Pythagorean theorem, it works for all triangles, all right triangles. So we can use it to be safe. And if you forgot the ratio, you don't see it here. So now we have DC, and we're looking for AD and AB, right? So we have, okay, so AB, let's go with AB corresponds to BD, right? So we're going to do proportions of AB. We don't have the hypotenuse for the big one, so we're not going to mess with that. But we do have the bottom, just BC, equals the corresponding part for AB, right, is BD, which is, all right, BD over, and then we have DC. Okay. And now we can start plugging things in. So we're going to get AB over BC, which is 10, equals, what does that equal here, huh? It equals BD, which is 6, over DC, which is 8. And again, we're going to cross cancel, or not cross cancel, we're going to cancel regularly and get 3/4. We're going to cross multiply and get 4AB equals 30. All right, I'm gonna draw this out here. So it's gonna be boom. Okay. And then we divide by 4. And we're gonna get AB equals 7.5. So now we have one part, right? It's asking for the sum of AB and AD. So we'll put that up here. Let's see what we can do with that. Okay, so now notice that in this one, it's the hypotenuse, right? So now we can do a Pythagorean theorem again. It's a 3, 4, 5 right triangle, but it's kind of hard to see the values here, right? But we can do it. So the 6 is the 4 value, right? So 6 to 7, so it's going to be, look at this. So we have 60, right? I'm just moving the decimal place 1 over, so it's 60 over 75. That gets you 4 to 5, right? So to find this part, we just do 7.5 times 3 over 5. So 7.5 times 3/5, right? We could do Pythagorean theorem, but I'm just trying this to show you a different method using the ratios. So 7.5 divided by 1.5 is going to give you 1.5. So this cancels out. So you have 1.5 times 3. So it equals 4.5. You know, I had all the space on the right, but I wanted to be close to AD. So we'll write it here, right? AD equals 4.5. So then here we have 4.5. Loving it. So it's asking for AD plus AB. So we're going to do 4.5 plus 7.5, right? Equals AD plus AB. And that equals 12. So AD plus AB equals 12. All right, all that work for a nice clean number, which I prefer to having all that work for an ugly number because it's just nice to have a nice number. Feels like you've simplified the world. So again, on this one, right, if you're lost on what to do, just try to find the pieces you can find, right? So you start with this part, right, which I didn't even end up really needing the DC. Well, I did use DC, I guess, but let's say I don't know whether it's going to help me or not. DC, I still find it because it's part of a right triangle that has 2 other pieces and it can inform me. And then from there, I can find AB, right? And then from there, I can find AD. And then from there, I add AB plus AD. And again, if you're confused on how I found AD, then that was a little different. I just used the ratios, right? I found that 6 over 7.5 equals 4 over 5. And I knew it's a 3, 4, 5. So that means this one had to be 3/5 of the hypotenuse. So I did 3/5 times 7.5. 7.5 divided by 5 is 1.5 times 3, 4.5. And then I plug that into my AD plus AB part, and I get 4.5 plus 7.5 equals 12. All right. If you have any questions on this question or on any of the ones before, or you want more questions like this, or to cover a different topic, let me know in the comments. I'm always happy to help with that. And if you like this video, please like the video and subscribe so we can keep seeing these videos and keep learning and get ready for the test. Enjoy the sun and the wind, and I'll see you all soon.